take a look at problem number 2. Factor the difference of two squares in a perfect square trinomial. So I got 16 z squared minus 40z plus 25. And first way we'll look at this is with the perfect square trinomial formula. And that says, for this particular one, if we have a squared minus 2ab plus b squared, then you can factor it this way. Versus, we also have another formula that says if you have a squared plus 2ab plus b squared, then you factor it in this manner. Now, I don't teach a perfect square trinomial because key number method will work on this, but let's see how it works here. First thing we'll do is you see if you can rewrite this as something times something else. This is 4z times 4z, so they're the same. That's what your goal is. We'll come back to the middle term here in a minute. And then we rewrite this as 5 times 5, so 5 squared. So this would be our a and this would be our b. So we're going to try to see if we can rewrite the middle as minus 2ab. For us to be able to use this formula, this here would have to be 4z, and this right here would have to be 5. So let's see. Again, that'd be our a, this is a, this is b, and this would be b. Well, 4 times 5 is 20, times 2 is 40, 40z. So it actually checks. So we can factor it as 4z minus 5 squared. That's the a minus b. A and b can represent anything. And that would be our answer. Now, again, it's kind of hard to have that memorized. So let's look at it with the key number approach. Now, if we use this real often, then it'd be worthwhile for students to memorize it, but we use it so seldom in math. You know, probably in a college algebra book, there's probably 2 problems that have a total. So I always tell them to use the key number. Even though it is a little bit longer, you know, when you got 2 problems in an entire book, then it's not a big deal. Z squared, z, no z, and there's a number for the z squared. So that tells us the key number. So we'll take 16 times 25, which gives us 400. So we got 1 times 400, 2 times 200, 3, no, 4 times 100, 5 times 80, 6, no, I don't think so, 7, no, 8 times 50, 9, no, 10 times 40, 11, I don't think so, 12, no, 13, no, 14, don't think so, 15, no, 16, 16 times 25, 17, don't think so, 18, no, 19, no, 20, 20 times 20. Okay, then we'll add them. 1 plus 400 is 401, 2 plus 200 is 202, 4 plus 100 is 104, 5 plus 80 is 85, 8 plus 50 is 58, 10 plus 40 is 50, that's 41 and 40. Subtract them. We got 399, 198, 96, 75, 42, 30, and 9, and 0. Now the number we're looking for is a number in our middle term, which is 40, which is right down here. So we're going to have 20 and 20. You're going to find that you'll see a pattern on these where these numbers are the same. Now our larger number, and these are both the same, but our larger number is same sign as the middle term, which is negative. The number I circled is in the S column, S for same sign, so if this one's negative, the other one is going to be negative. Factor by grouping. These have a 4z in common, and that gives me 4z minus 5. These have a negative 5 in common, and that gives me a 4z minus 5. Now they both have a 4z minus 5 in common, so I'll factor that out. And we'll cross out this to see what goes in your second set of parentheses, which is 4z minus 5. Or you can write it as 4z minus 5 squared, which matches 4z minus 5 squared, A.